are left. Remaining amount is equal to how much? First year is equal to 50 lakhs. After second year, how much? 30 lakhs. After third year, how much? 20 lakhs. Okay, like this one. Okay, remaining is equal to this one. So this graph is equal to exponential decrease. Okay, now. So this is equal to radioactive decay law. So here two equations. One is equal to dn by dt is equal to minus lambda n. Again, final equation is equal to n is equal to n naught into e to the power minus lambda t. Okay, I derived this equation last week. Okay. Again, next I told half life also. 1 second half life here. Okay. Suppose initially here the number of nuclei present is equal to suppose. So 1, 2, 3, 4. Again 1, 2, 3, 4. So like this one. So total how many nuclei this is equal to 16. Okay, 16. After the half lifetime, the number of nuclei is equal to this one is equal to exactly 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this one is equal to T of. Okay, this is equal to here the n naught by 2. So initial is equal to n. So exactly half of the value here. Okay. The time interval during which this radioactive sample or radioactive material so falls half of the initial value, So this one is equal to n naught, this is equal to n naught to 2, okay? Suppose this is equal to 16, this is 16 by 2. Falls half of the initial value. The time taken is nothing but half lifetime. Okay, again next one is equal, again next one. Suppose this one is equal again 1, 2, 3, 4, again 8. Again, only 4 minutes from this side, this is equal half of the value. So this is equal again half minutes, this one is T off. From beginning is equal to how much? This is equal to 2 T off. So this one is equal to how much here? So n naught by 2 by 2, that is equal to n naught by 4. Clear this one? So n naught by 2, again next one n naught by 4. Okay, again next one. Again some more time is equal to here. Again this value is equal, this one is equal to 2. Again this is equal, what is the value? So this is equal again next to half lifetime. So this is equal to n naught by 4 by 2. So n naught by 8. Okay, so this is known as half lifetime. Majority of the questions remaining application depends upon this equation. Okay, so what is the statement? The time interval during which the radioactive material falls half of the initial value. Okay, falls half of the initial value. So the time is known as half lifetime. The time is equal to half lifetime. Okay, I think this one is completed. Okay, now so next one after this one again average lifetime. Continuation, average lifetime. Average lifetime. So average lifetime. The symbol is equal to, the actual symbol is equal to tau, but again I am using the T average. The half life symbol is equal to T 1 by T half. Okay, average lifetime is equal to T AV or AVE. So average lifetime. Okay. So this also completed. So once again I will repeat this average lifetime. So this is equal to, this one is equal, T average is equal to the total lifetime of all the nuclei is divided total number of initial or original nuclei. So this is known as average lifetime. So this is the one statement. I given again two more definitions also. So initial statement, initial definition is equal to the total lifetime of all the nuclei is dividing with the total number of the original nuclei. Okay. So again, suppose in our classroom, how many students are there? Maybe 40, 50, 60 students are there. Okay, now 50 students. Okay, the lifetime of the individual students is equal to how much year? Suppose some students, some persons may 50 years, 60 years, 70 years. Okay, now the lifetime of all the students by total how many students are there here. So that is known as average life of this classroom also. Okay, suppose one student lifetime is maybe 100 years. Okay, now again next one. Second one is equal again next second person is equal again 50 years. Again next one 30 years. The lifetime of all the nuclei again by again number of the students. So that is known as the average lifetime. So what is the final equation is equal here? This final equation is equal to 1 by lambda. So T average is equal to say 1 by lambda. So this is the final equation. So in your mind, so you have to practice this last equation. So T average is equal to say 1 by lambda. What is statement according to this definition? So this one is equal to here the reciprocal of the reciprocal. So dk constant is known as, so dk constant is known as average lifetime. Okay, in the examination part you have to write this one or this one. This is very simple also. Okay, so T average is equal to the reciprocal of the dk constant is known as so average lifetime. Okay, now I told one more definition also. So one more definition with the starts, that is important one. What is n is equal to equation? So n is equal to say n naught into e to the power of minus lambda t. Suppose the time t is equal to t average. Suppose if t is equal to the average lifetime is equal to this t average is equal to t. So what is that equation? So n is equal to say n naught into e to the power of minus lambda into t average. The t average is equal to what is that equation? 1 by lambda. Okay, 1 by lambda. So what is that equation? So n is equal to say n naught into, so e to the power of minus lambda into t average is equal to 1 by lambda. 1 by lambda is cancelled. Okay, now so 1 by lambda is cancelled. So n is equal to say n naught into e to the power of minus 1. E to the power of minus 1. So e to the power of minus e. So this 1 by e. 1 by e is equal, what is the value? 0.37. So this is equal to 0.37 into n naught. So this is equal to one equation. Okay, now or this is equal to 37% of n naught. So here n is equal to remaining. The remaining is equal to here the n. So n is equal to 37% of the n naught. Okay, now. 37% remaining means here how many nuclei can decay is equal to the, how many nuclei can decay is equal here? So 63%. Okay, now 37% left, 37% remaining. I told you, okay, from 1 crore to last final again having the 4 lakhs on here. So how much amount donation here? 96 lakhs donation is here. Okay, 96 lakhs. Okay, same this also 37% remaining. So how much again percentage of the decay is equal? 63%. Okay, so that means 63% decay. So in this equation, so undecayed is equal, undecay or remaining is equal to undecay or left or remaining is equal to how much? 37%. Okay, now so again next one, decay is equal to how much here? So decay is equal to 63%. So now according to this value I will give one definition. The time interval during which the 63% of the nuclei, the activity of the 63% of nuclei cannot decay from initial value. Okay, from decay initial value. So that is known as so average lifetime. Okay, now the half life again average same definitions also. The half life means again it falls half of the initial value. So this is equal again false again how much? 63%. Okay, now so once again see this definition. The time interval during which the activity of the radioactive material falls or decay 63% of the initial value. 63% of the initial value. So the time is known as average lifetime. The time is known as average lifetime. So one is complete. Okay, now again next. Okay, so this is equal again n is equal to 0.37. Okay, this is equation. Again next one. Again So this decay 63%, okay? Okay, next one. Write down the relation between, note these values. The relation between, note these values. The relation between average lifetime and half of the lifetime. The relation between the T off and T average. T off and T average. T off and T average. So what is the T off and T average? What is the T off is equal to that equation? This is equal to say 0.693 by lambda. So 0.693 by lambda. Again, next one T average is equal to what is that equation? So 1 by lambda. So now dividing these two equations. So T average by T off is equal to, so 1 by lambda by 0.693 by lambda. In this equation again lambda and lambda is cancelled here. Okay now? So this is equal to T average is equal to 1 by 0.693 into T off. Okay, T average is equal to 1 by 0.693 into T off. What is 1 by 0.693 value is equal to here? So this 1.443 T off. So T average is equal to. Now tell me here, which value is more, average lifetime or the half lifetime? Average lifetime is almost more than the 1.4 times. So 1.4 times of the half lifetime, or nearly 44.3% of the half lifetime. Okay now? So one more relation, the relation between the T average and T off. The T average is equal to, so T average is equal to 44.3% more than T off. Otherwise simply 1.443 times of the T off. So please note this equation. So this is a relation between the T off and T average. Okay, next one. So please show to me according to this graph is equal to. Now what is the graph position is equal? Same as previous graph also. The time value is taken on x-axis. Okay, next one, the number of nuclei undecayed. The number of nuclei left. Value is taken on y-axis. So simply this one is equal to n. So n value is taken on y-axis. So initial is equal to n naught. The number of nuclei at the initial is equal to n naught. What is the graph position is equal? So exponentially decreases. Okay, now exponentially decreases. Okay. So what is the condition? The number of nuclei falls half of the initial value. Suppose at this point is half of the initial value. So this one is equal to T off. Hence this is equal to T off. So this value is equal to n naught by 2. Clear? So this one is equal to half lifetime. Just now I drawn this graph also. So here we taken the 16 nuclei. So this one is equal to 8. So this time is equal to half lifetime. Okay. Again, next one is equal again. This is equal to average lifetime. So this is equal to T average. What T average? What is that equation is equal to here? See this equation. So n is equal to n naught into e to the power of minus 1. So n naught into 1 by e. So this is equal to n naught by e. It is not completed. Completed. Okay, now please write down. So this one is equal to n naught by e. Again, next one. So this is the average lifetime and again half lifetime graph relation. Okay. Again, next one more application for the half lifetime. Please note down. Especially for the objective point of view, I think this one also completed for online students. Okay. Once again. one application. Application. The number of radioactive nuclei, or simply in the bracket radioactive sample, undecayed after n half lives. Especially for the objective point of this application is a very important one. You have to do some very simple technique for this application. The number of the radioactive nuclei or radioactive material or radioactive sample undecayed. So undecayed means remaining after the n half lives. So what is that equation? After the n half lives means here this n is equal, this t is equal, what is that equation? So n into t half. Clear? The total time is equal to n half lives. So the total time is equal to n half lives. So this is equal to n into t half. So this is equal, what is that equation? So n is equal to say t by t half. Please note this value also, small n is equal. So small n is equal to say t by t half. After the n half lives, this t is equal to say t by half. So n is equal to t by half. So tell me what is that equation? So this is equal to one technique for objective point of view. So n by n naught is equal to say 1 by 2 to the 4 half. So t by t half. So this is the one equation. So again next one more equation, n by n naught is equal to say 1 by 2 to the 4 half small n. Don't get confused, one is equal to say capital N, second one is the small n. The small n, capital N means here, small n is nothing but the number of the half lives. Clear? So again this is equal to n is equal to t by t half. This is the number of the half lives. Again capital N is equal to the number of the nuclei undecayed. Okay? So don't get confused. If you confuse it means I can please that down. Here the capital N is equal, not down. Here capital N is equal to, not down. Capital N is equal to the number of nuclei undecayed. The number of nuclei undecayed. The number of nuclei undecayed. Undecayed. Again next one. Again next small n is equal to number of half lives. So number of the half lives. The n naught is equal to the initial. Please note down. So n naught is equal to that also please note down. So n naught is equal to initial number of nuclei. Initial number of nuclei, that means the number of the nuclei at t is equal to 0. That also should mention t is equal to 0. T is equal to 0. Again. Now again, sir, how this equation came, sir? Please again derive that equation n2 to the power of n. How that equation? So first part here, after the half life. first half, both sides should remain same. So 1 by 2 to the power of 1 is equal to 1 by 2 to the power of 1. So LHS is equal to RHS. Okay, this is the one. Next one. Second one is equal, suppose after the 2 half lives, let's note down one sum. Half life is 10 minutes. 10 minutes. If initially there are number of nuclei, find the for the disintegration of disintegration of 450 nuclei. For a radioactive material, one radioactive material, half-life is 10 minutes. Half-life is equal to 10 minutes is given. So initially there are the 600 number of nuclei. Initially is nothing but this is equal to N0 is given. So please note down N0 is equal to 600. Find the time taken for the disintegration of the 450 nuclei. So disintegration of the 450 nuclei. Yes, please note down. The initial how much this is equal, N0 is equal to 600. Clear? Time is 10 minutes. Okay. Again, next one, number of nuclei, find the time taken for the disintegration of 450. Decay is equal to how much? So decay is equal to, this one is equal to 450. We need decay or undecayed? Undecayed. Is equal to undecayed is equal to. So undecayed, this is equal to N0. N is equal to. So N is equal to how much? So this is equal again 600 is equal initially, again decay is equal to 450. So remaining is equal to how much? This value is equal to here the 150. So undecayed is equal to say 150. Undecayed is equal to 150. So now again, so half-life time T off is equal to say 10 minutes. T off is equal to say 10 minutes. So what time is equal, T is equal to how much? Time T is equal to how much? Yes, to do the sum. So what is the equation? So I given one small technique for the objective point of view also. What is the equation? N by N0 is equal to N by N0 is equal to, so 1 by 2 to the power of T by T off. Clear? So N by N0 is equal to 1 by 2 to the power of T by T off. N is equal to how much? This is equal to 150. So again N0 is equal to how much? This value is equal to here the 600. So which value is equal to 1 by 2 to the power of T by T off. The T by T off is equal to here the 10 minutes. 150 ones are 150 fours are. So 1 by 4 is equal, 1 by 4 is equal to 1 by 2 to the power of T by 10. 1 by 4 is nothing but what is the value? 1 by 2, 2. So 1 by 2 square. Tritium having